All right, so hi everyone. My name's Kir, and today I'll be sharing a couple of features that were recently added to funcX, which are funcX executors and the async API. So as Kyle said, just to introduce myself real quick, I'm an undergrad at the University of Chicago studying computer science. I've been working on funcX for about a year now, and adding the new async and executor interfaces was one of my first big projects. So to see the motivation for introducing new executor and async interfaces to funcX, let's look briefly at the current funcX result fetching model. So we'll start by defining a basic demo function that I'll use throughout the presentation, double delayed. So this function just sleeps for 1 second and then returns the double of its input. And this is just simulating a function that takes a little bit of time. So no real work is being done here, but it's just a demo function. And I'm using the tutorial endpoint here, but you could plug in your own endpoint ID if you spun up your own funcX endpoint on your local machine or whichever machine you want to, if you wanted to try and run this code. So as you can see in our existing funcX model, it requires us to query periodically for a task result over HTTP if we want to get our result back quickly. And in this case, we're querying every second to try and get our result back, sending our get result over HTTP every second. And once we get our result, we print it out. So what we'd expect to happen here is, since our double delayed function takes 1 second, we would expect it to print out task pending, and then hopefully within 1 second we get our result, which is 50 doubled, so 100. And preferably what we'd like is a model where we can get our result back as soon as it's ready, rather than querying over and over again. This model of querying over and over again is fine for the fire and forget method, where you fire off a bunch of tasks, potentially not caring when you get them back. But what we've introduced is the async API, which uses WebSockets to retrieve the result as soon as it's ready, rather than having to query it over and over again. So now let's look at how this model actually works internally. So here's our stack on the right, our web services, and on the left, you'll be running your funcX SDK using the async API model. So this model introduces the new WebSocket service, and keep in mind that from a user perspective, this functionality will all be wrapped up in a single async run function call, as we will see shortly. So this is internally what's happening. So we start by submitting our task over HTTP. This is the same submission method as with the existing funcX model, allowing us to have a centralized place where tasks are submitted. From there, it gets sent to an endpoint to be executed. Now, here's where the async API diverges from the existing API. Internally, it recognizes that there's an outstanding task and forms a WebSocket connection to receive the task results. Next, the task completes and gets passed over to our WebSocket service. As soon as the result is available, it gets sent over to the WebSockets to the user, removing the need for the user to query over HTTP regularly. And finally, internally, we do cleanup and close the WebSocket connection, since there are no more outstanding tasks. So in practice, what this actually looks like, even if you're not familiar with async code in Python, I think it'll be pretty clear what's going on here. Again, we're using the double delayed function. So first, note that we set asynchronous to true when we initialize our funcX client. Once again, we're using the double delayed on an input of x equals 50. And notice that in async mode, we're using the exact same fxc.run funcX client method to get our result, except in this case, it's no longer returning a task ID. Instead, it's returning an awaitable async task. And if we were doing a batch run, for example, we would get back a list of awaitable tasks. So everything that we say, everything that we saw previously about WebSockets is wrapped up in this single await fxc.run line in this async task. The very last line runs the async task function on fxc.loop, which the client creates if you don't pass in your own event loop in the client. And also note that this very last line should be replaced with await.task if you are running this in Jupyter notebooks, since a Jupyter notebook already has its own event loop running. So the output of this should not be too surprising. It should just print 100 because we've doubled 50, and the result will come back as soon as it's ready, once we've awaited that fxc.run awaitable that was returned from that function. Now, what I think will be more useful to most people is the funcX executor, which is built on top of the async interface. And as we'll see, the funcX executor uses the async interface internally, running the WebSockets under the hood on a separate thread. So let's take a look at this funcX executor class real quick. This is a concurrent function, concurrent futures executor, sorry. And currently the key method that it implements is the submit method. It takes a function and arguments as well as an endpoint ID that the function should be executed on. And also note that this executor runs the async WebSocket code on a separate thread under the hood, as I mentioned. So it's using the async interface under the hood. It should perform just about the same as the async API that I just showed you. So let's take a look at an example of this. Basically the same as async, but without async code being run. So hopefully a little more user-friendly. The first key line is we initiate the funcX executor, which all that we have to do is take in the funcX client. Next, we pass in our double delayed function that we've been using as the example and our input X of 50. And the actual blocking part, or the main blocking part, is our future.result call, which will wait until the future is ready and print our result after it's been executed and received back over the underlying WebSocket connection. And once again, it should just print 100. So no querying, just waiting on the WebSocket, and as soon as the result is ready, the future will receive the result. And a new feature that's coming and being added onto this is the executor batching, which is a feature that can be credited to Zhuzhou. I'll run through this real quick since I don't have too much time, but basically, obviously you want to see if this is performing well. So I've added a little timer around all of this, but this is just submitting 50 tasks. Notice the difference is that I've set batch enabled to true and added a batch interval, which essentially means that every 1 second, the funcX executor will accumulate a number of submit calls that have been built up. And as soon as a second passes, it'll submit all of them in the form of a batch call rather than a bunch of HTTP calls for each submit. So it'll batch them into a single HTTP submit initially. And then after that, we can receive all the futures and call for their results and print them out as they come back sequentially. And just a basic run on my laptop, I ran this under 10 seconds. So what's next? We need to do some robustness improvements, make sure nothing bad happens if connection is lost with WebSockets, and we need the ability to recover tasks if they were submitted but never received. And also task cancellation will be coming eventually. So in summary, existing HTTP query model works fine for fire and forget. And it's also great for long running tasks. Async API is better for speed and complex async use cases. funcX executor is equally good as the async API for speed, since it's just a thin layer built on top of the async interface. And I think it's more user-friendly. And in both async API and executor, you can forget about the task ID and just receive the result. Questions about that?
Thank you, Kir. I'll just make one statement there. So most of what Kir spoke about is actually already in production and being used by people like Eric, so scaled up to several 100,000 functions running. The last stuff, the batching, is not yet there, but that'll be there shortly. It's not yet in our docs or in our tutorial, and that's sitting on me to do that. So I apologize. Kir's done all the hard work up to that point, and now we just need to publicize it. So we welcome people trying it out, giving it a try. I think it actually will make life a lot easier. So questions for Kir instead of me rambling. Does anyone have any questions? I saw Ben posted something. What did Ben post? Oh, Ben.
So, just a comment. Thanks.
Yeah, so looks interesting. Batching of, yeah, the batching thing is super useful because that's obviously the big overhead for us, is making a bunch of REST requests, HTTPS requests.